Welcome back to Programming Slither.io in Python, and today I'm going to be doing a brief discussion of vectors, and this video is also going to be short. It will help us with camera movement in the next one. I want to explain what a mathematical vector is because our camera is going to rely on this, and our improved player movement will also rely on vectors. So I've gone ahead and I've drawn a simple 2D graph. So this is the x-axis and this is the y-axis here. And to explain the difference between a point on the graph and a vector, let's say I have a point right here, and this point is at the position 10, 10. That means it's 10 units to the right, 10 units up. The difference between a vector and a point is that the point just marks a location, but a vector, an identical vector of 10, 10, would be a direction to that point here. So this vector also has the x and y value of 10, 10, but it's a direction to that point. And this is useful because if you add a direction to a position, let's say I have my player in the middle of the screen here in pink. Okay, let's say I have my player's in the very middle of the screen. The player's position is 0, 0. If I want the player to move to 10, 10, I need to add a direction vector that points him that way. And so I could just add the vector 10, 10 to the position. And when I do that, that would make the player move off to the side in that direction. If I add 10, 10, the player is going to be here. Now let's say I wanted the player to not move in that direction quite as fast. Maybe instead of adding the direction vector 10, 10, maybe I could go with something a little smaller. I could instead add the vector, oh, wrong tool, I want line. I could instead add the vector 5, 5, which is half the distance. Now notice, 5, 5 points in the exact same direction, but it doesn't cover the same distance, which means that the player would be moving a little bit slower. And so what we're going to do today is we're going to take our orbs and we're going to practice using vectors by adding different direction vectors to make our orbs move. Because if you want movement, you simply add a vector to a object. And that's what I'm going to visualize here. Let's say I'm going to ignore this stuff. So I'll cut some of this here. So now we're back to our player in the middle of the screen. What if I wanted the player to move up? Then I would add the up vector, which would just be, I want blue. It would just go straight up, and the numbers I would choose for this would probably be something like 0, 1, because the x is not changing at all, we're just moving up, and the y changes by 1. So this is a good up vector. It wouldn't move the player too quickly, it would move him up 1 unit every single time. So if you add this vector to the player's position, which is 0, 0, the player will now be at that position. If I wanted to make the player move to the left, then I would add a different direction vector. This vector would be -1, 0. Because we're not changing the y, we're only moving left, and because we're moving left, the x is negative. And so these are good direction vectors. You can do all kinds of direction vectors. You can go diagonal by doing something like 10, 10, like what I did earlier. And notice, if you did a bigger number, like let's say I wanted to move to the left, but I wanted to move faster, I could give it a bigger direction vector with the value, instead of -1, 0, it would have the value of -6, 0. So it points in the exact same direction, but the player, every single time I add this to the player's position, the player is going to be moving a little bit faster. I'm not just moving by 1, I'm moving by 6 every time. So this is how I always think of vectors in game development. It's just an arrow that points to a certain position, and when you add that arrow to a player or an object, it will move in that direction. And how fast just depends on the numbers that you use. But before I confuse you anymore, we're just going to move on and add this to the code. So I have all the same code from last time where, oh, I clicked debug, I don't want that. I have all the same code as last time where the player just eats the orbs and nothing exciting happens. We're going to make these orbs move around in certain areas. And that's going to be pretty easy because of the way we've already coded the orb. It's already in its own class, which is good and organized. And it already has an update function. So here's what we're going to do. We're just going to give it a velocity vector. So in its init function, in its constructor, I'm going to give it a velocity, self.velocity. And it's going to be a list, and it's only going to have two numbers in it, x and y. And I want to start. I want the object, I want the orbs, all of them, to move straight up. Now, in this example, I said straight up was 0, 1, but remember from a previous video I said Pygame graphics flips it around. So the y-axis, as you go higher, your y is getting smaller, and as you go down, it's getting bigger. So it's going to be 0, -1. So its velocity is going to be the vector 0, -1. And what we should do is in the update function, we're just going to add that velocity to the position. That's how you make a vector move a character. You add it to a position. So inside the update function, where we, before we do the collision checking, we're just going to do that. Self.rect.x, and then we'll add the x velocity, plus equals self.velocity.x. Nope, .x. And then, man, it's doing that weird autocorrect thing again. Self.rect.y plus equals self.velocity.y. And so now we're able to apply the velocity vector to the positions. So let's see what this does. No attribute self.rect.x. Why is it saying there's no attribute? Oh. Okay, I got carried away here. It would be actually velocity 0 and velocity 1, like that. Because we're accessing elements of a list. Only the Pygame rect has its own built-in x and y, but we got to use the index. So if I apply this, now you see all the orbs are moving up because they all have the up vector applied to them. Now let's do a different vector. Now let's make them move down like that. Just switch the direction. And then to make them, which way should we make them? I want them to go up and to the right. So that would just be 1 for the x, we're going to move it to the right, and -1 for the y, we're going to move it up. And like that, now you have all the orbs moving diagonally using a velocity vector. Now, what I didn't mention about vectors is that they can also be added to each other. So say I had two vectors. I had see, I call this velocity, and that's a better name, but I'm going to replace it. Let's say I had a left vector that was just -1, 0, and then a self.down vector, which is going to be 0, 1. If you add both of these vectors together, I would get -1, 1. And I'm actually going to change this back to velocity. What I'm trying to explain is that when you add vectors together, you can get combined results like this. They're moving both down and to the left. And that's what's useful about vectors. You can add as many of them together as you want. You can have one move down and another move to the right. And then your final product is one moving this way. And that's what we just did. So some of you didn't really need this tutorial, but I think it's helpful to visualize vectors like arrows, and I hope this helps for the next one as we get into more advanced camera movement.